I want to do two more examples to help you through this section. The next one says, create an identity for the expression 2 tangent theta secant theta by rewriting strictly in terms of sine. So they give you some parameters to follow along the way. So unlike some previous examples, we're not trying to get to the point where it's equal to something. We want to get to the point where it's just in terms of sine. And so a couple of things that I want to remember as I work through this, so just some side notes here. We know that tangent x is equal to sine over cosine. And so the first thing I'm going to do is keep my 2. And instead of tangent, I'm going to write sine over cosine. You want to be very organized and detailed with this as you're writing it out, as not to lose anything or accidentally mix up something and it destruct your end result. I also want to remember that secant x is equal to 1 over cosine x. And so secant x, I'm going to rewrite as 1 over cosine x. So I'm at least heading in the right directions. It's not in all terms of sines right now, but I've got some good tools for myself to work with. I'm going to put these together. So I'm going to say it equals 2 of sine x over, I'm just going to multiply across the tops and the bottom. Now this is a 2 over 1, so 2 just stays on top. Cosine and cosine give me a cosine squared x. Now my goal is in terms of sine. And so I need to manipulate this bottom here. It's my only thing that I have left to do. And I remember my Pythagorean identity that we started off the very beginning of this section and chapter with, and that's sine squared plus cosine squared equals 1. So instead of cosine squared, I can move sine squared over here and say that that's 1 minus sine squared x. And so now I have written this expression strictly only in terms of sine. And so just kind of some side notes that help me get there. Now this next one is a little bit tricky. It says use algebraic techniques to verify this identity. So I need to go from one side to the other. And it says hint, multiply the numerator and denominator on the left side by 1 minus sine theta. And there's a reason they're giving me that hint, so I'm going to work with that. And they mentioned the left side, so that's going to be the side that I start with in hopes that I can get down to that right side. And so I'm looking at cosine theta over 1 plus sine theta. I'm going to apply this hint. There's a reason they typed it in there. So 1 minus sine theta over 1 minus sine theta. That is just equal to a big old 1. So I've not changed the value of the problem any. If I distribute across the top and bottom, this gives me cosine theta times 1 minus sine theta all over 1 plus sine theta 1 minus sine theta. Now we've seen that denominator before. I'm not going to distribute out the top yet. I want to look at this bottom. It looks real familiar. If I go and I multiply this, this is the difference of two squares seen earlier in this lecture. So this would be 1 minus sine squared theta, distributing the 1, etc., etc. I also know that that goes back up here to the Pythagorean identity. 1 minus sine squared is equal to cosine squared. We actually applied it here. So this would be cosine theta times 1 minus sine theta all over cosine squared theta. Now I didn't want to distribute this out because now that I have multiplication on top and a denominator, I can simplify right here. And so this would cancel with one of these, leaving me with 1 minus sine theta all over cosine theta. And note, that's exactly where we were wanting to end up. So some neat things are happening in this section. I hope you enjoy this section as much as I do. These last 3 are going to help you with your homework problems 4, 6, 8, and 9. There's not a lot of homework. There's only about 10 problems on this section. So I hope these notes help you out along the way. Contact me if you have any questions.